Hi guys, my name is Ajit and welcome to my YouTube channel. So today in part 21, we will build and visualize decision tree from scratch. So in this video, we will write machine learning equations to build and visualize decision tree from scratch. We'll also use graph-based library to visualize decision tree at the end. In the last video in part 20, we discussed about finding best feature and split value in decision tree. So if you are not familiar with this topic, I would recommend you to watch my part 19 and 20 video. So let's start with quick recap on part 19 video. So we have used ice dataset and we have split our value to x and y, then we converted numerical target variable to categorical. So I have explained all these things on my part 19 video. So you can view my part 19 video. So it's there inside the playlist. You can see part 19 inside Android and Coursera machine learning in Python. You can see all sorts of equations that I have written from scratch, and I'm still writing these equations, and you can follow my part 19 and 20 for decision tree. Okay, so this was the visualization that we did last time. This was the split that we did without machine learning equations for entropy, Gini index, and we did all sort of interpretation. So this was all done in my part 19 video. Okay. Then we took a sample example of COVID-19 data and did all sort of manipulation to find out best information gain. So these are all things that we did last time, and we were able to find out the highest information gain would be my first feature to split data in decision tree, which was fever feature. So and then in part 20, we started building decision tree. So these were the 9 steps to build a decision tree. In part 20, we did till best split, determine best split. Till part 7 we completed, and today we will start with part 8, which is to build decision tree. So without a function to check the purity of decision tree, then without a function to classify my decision tree, to split data, to calculate entropy, to calculate overall entropy and Gini index, to do a potential split. So we did all this in part 20 video, and then we were able to find out my best split feature and value is petal width, and the split best split value is feature is petal width, and best split value is 0.8. Now we will write a complete algorithm to build a decision tree. So we are in step 8. So we will merge all this function that we have written, and we will build a final decision tree, and then we will do visualization of decision tree. Okay, so let me start with writing function def decision underscore tree underscore algorithm. I will take df. Df is the data frame where I have this data set, df.head. Okay, now to build a decision tree, first I need to check impurities. If I don't have any impurities, then I will stop my decision tree because that would be my leaf node. So first thing would be to check the impurities. Yeah, so So first thing would be to check impurities. Why we will check impurities? Because so if I don't have anything to split, then that would be pure node. If I have nothing to split, right, then that would be my pure node, and then I don't need to further split anything, right? So my first step would be, so my what would be my first step? Mm, so first step would be to check this tree, this to check this decision tree, if this is my leaf node, this is my leaf node, then I don't need to do any split. For that we have written potential split function, right? So what potential sorry for that we have written check impurity function. What it does, if the count of my dependent variable is 1, that means I only have one dependent variable, then I don't need to do anything, then I will return true, and I will classify the tree. I will only classify the tree because I only have one dependent variable. So my first condition would be, so my first condition in decision tree would be to check if I have any leaf node or not. If check impurities bracket data, if I don't have any leaf node, then I will do classify equals classify equals classify data bracket df, and here I will return my classify. Okay, this means I don't have anything to split, that's why I will return simply the value that I have in my dependent variable. Else, otherwise, if I have something to split, what I will do, then I will do a potential split. Potential split is nothing, just taking the average of two value, taking the mean of two value. So if my node is leaf node, then I simply check my impurity. I only have one node, so I will return that node. If I have multiple leaf node, multiple thing to classify, then I will do a potential split, where if only one dependent variable variable, that means I have nothing to split, then I will simply return the variable. Okay, when I will do potential split, if if we have more than one dependent variable, then we will do potential split. Okay, so after doing potential split, what we need to do, so I need to pass here df. Okay, so after doing potential split, what we need to do, I need to break my data into, I need to find best split on the basis of potential split. Okay, then I do, when should I do potential split? When I have more than one dependent variable. Then after getting potential split, I find best split, best feature. So then I find best feature. If you don't know what is best feature, and if this is not making sense to you, then I would recommend you to please watch my 19 and 20 video. Okay, and this is to find best feature and split value. Okay, On the basis of best feature and split value, we will split our data now. So we have already written a function to split data. Yeah. Split data and data underscore below comma data underscore above. Column underscore split column now will be now best feature. Split value will be split value. Okay. This is to divide, split, split, split the data. Okay. Now what I will do is I will store this information in our tree. Okay. So inside tree, I will give formatting option like this so that I can denote this as a tree. Okay. Dot format. Here I will store best feature and best split value. Okay. Now let me return my function. Let's see what would be the output. So this has to be inside. So let's remove data now. Let's see if this is working or not. So here you can see the check impurity is taking the value of -1. So we need to convert this df to, so df we need to convert this to numpy array. Okay, because we are the function is the function check priorities is built on the basis of numpy array. Okay, so data equals df dot values. Let's change this to data. Okay, now this looks good. Okay, now if we run this, so let me print tree. So you can see here the first tree is printed here. Okay, so this would be your this uh, tree is, so if you look at df dot head, 3 is your third feature, 0 1 2 3. So your petal width is 3 and your best value to split is 0.8. Okay, so now we are able to figure out my root node is this is petal width 3. Okay, now I know I need to split data on the basis of, so I have two value here, data below and data below and data above. So I know I need to split my data into two parts now, here and here. And this node will have data below. Okay, data below means petal width of less than 0.8. Okay, less than equals to 0.8, and this node will have petal width greater than equals to 0.8, which we have stored here, data below and data above. Right, now what we need to do, we need to again split our tree until we get the best splitter. So again we need to split this information. Right, for that what we need to do, we need to again run this function. Right, for that what we need to do, we need to use a recursion. Okay, so if you are new to recursion, what recursion does is, suppose if I need to calculate a factorial of something value. So let's say if my x equals 1, then I will return 1. Else, else I will return x times, again I will call this factorial of x. Okay, factorial of x minus 1. Okay, so if I pass here factorial of 3, and what I get 6. So what this does, this calls the function by itself. If I pass 2 here, it will give 2. So what this does, this function, so what I did here, so def factorial of x. So if my x is equals to 1, I have returned 1. Else what I did, x time factorial of x minus 1. So if I pass 2 here, this will go in else, and what it does, 2 times factorial of 2 minus 1 1. Again this factorial of 1 goes here. Okay, that becomes 2 times factorial of 1. So again the factorial of 1 goes here, and if x is equals 1, return 1. So 2 times 1, this becomes 2. Okay, so same, so what it happens is it calls the function by itself again and again, again and again. So for factorial, if I pass here 3, it will again, it will be 3 times factorial of 2. Okay, again 3 times factorial of 3 times 2 times factorial of 1, again 3 times. It will call itself, it will call itself again and again until we get x as 1. Until we get x as 1, it will call again and again. So what recursion does, it calls the function itself. So this is calling the function itself, right? So we need to use the same logic here while calculating decision tree. So why we need to use recursion? Because we need to split our data. Again we need to look best feature here again, and we need to split our data on the basis of the best feature. For that we need to run recursion. Okay, so let's learn recursion. This one is to store result in a dictionary. Okay, now let's say true. So we will have answer as true and false, right? So let's say true equals true. If we have true, then call this decision function again. If we have false, underscore answer, again I will call, but this time this will be below. So true will be data below, and false will be data above. Okay, so this is the recursive reference function. Now what we need to do is we need to store this value inside a tree. Okay, so that we can see, we can visualize the information. So tree dot bracket, let's store this information inside subtree. Subtree equals tree with empty list. Now we will store subtree bracket tree dot open true underscore answer. Underscore. So why did we append this value? To visualize the result. Open it the split. And now let's return soft tree. Okay. Now what this value says is, it says like df dot. So what this happened is, so now this is a recursion function, guys. So this is the recursion function. So this data dot df will create one time. We will create one time. But again, if this recursion runs, and again you will see that this data has already been created, right? So it tries to create this again, but since it has already been created, so it throws an error. Okay, so for that what we need to do is, so we want to create this function only one time. Okay, so for that let's give a counter, so that in the counter of 0, in the first counter, if my counter is equals to 0, in first counter only, in first counter we create this value, data equals data, else data will be equals to df. Okay, so in first counter only we will create this data as data.df. Okay, and in second counter it will already, it will again, we will already have this data. So in else, whatever we have in df will be stored in data. Okay, so if we do this, then it should work now. Object has no attribute values. Oh, we need to pass this counter here, so that in next time this is not repeated. Also we need to increase the counter, so that we know in first counter this has already been done, and in the second counter the tree is running. Okay, now if we check, this is my tree, you can see here the tree structure has been implemented. Okay, now let's do a ppprint. You can see here the tree has been implemented. So my root node is this, and then my first split node is on basis of Aristotosha. Okay, and then again my another split is this, and so on. Okay, so let's change this value like 3 to the columns. So my column here is, so column for 3 I want to have the column name. So 3 is my pedal width. So let's change this 3 to pedal width. Okay, for that what we need to do is, let's add a column header. Column header equals df dot columns. Okay, so my feature will be equals to column header bracket split value. So then we need to pass this here. Column header bracket is missing here. Oh, sorry. This should be in a list. So what this error is telling is, so this is a local variable because the recursion is calling this again and again. So in the next iteration, this field is is not considered as the global variable. So we need to first define this as global variable. So okay, now let's check. Okay, now this looks much clear. If we do ppprint, now you can see this looks much clear now. So what I did is I simply added the column. So what I did is, so your columns, if you see df dot columns, so these are my columns, right? So my value was in third column, right? 1 2 3. So what I did, I passed here 3. If I pass here 3 1 2 0 1 2 3, this will give me petal width, right? So this is what I did here. So df dot columns is what I stored here, and column name bracket, this df best feature will have value 3. Okay, so I have passed that here. Okay, so this is to get column name. Okay, so once we do this, you can see you can visualize our decision tree. So we can visualize decision tree through graph based library even. Okay, so I have given the data frame -1. So this will -1 here. This will give you simple your independent variable, and this will give you your dependent variable. So I have passed that x and y here. Okay, now if you see this, if we use graph base here, and if you give your feature name and target variable name, then you can visualize your tree. So you can visualize your trees, and the petal width, the first splitter is petal width with less than 0.8. So this is what we got. Yeah, and then is a petal width with less than equals to 0.1.75. So this is the second split, and so on. Okay, so we can do this visualization through graph visible. Okay, now what we want to do is we want to even add the minimum sample and the depth of the tree. Okay, so we can add, I want to add minimum sample. Let's say my minimum sample is 2 and maximum depth is equals to 5. Okay, so here I will add condition if length of data is less than or equals to minimum length. Okay, or my counter is less than, if my counter is equals to maximum depth, then I don't want to call this recursion function. Okay, so let's see if this is working or not. So if I give minimum sample equals 60. 60 is working. And if I give the maximum depth to suppose 2, this is not working. Oh, I need to pass this parameter here even, so that it calls recursively. Let's see, the depth is, this is working. Okay, the minimum sample say 16. Okay, try increase my depth 4, 3. Okay, this is working fine. This to 4. Okay, this is working fine. Okay, so this is how we design a decision tree and then visualize our information. And even we can use graph base to do the visualization. So this much was for today's lecture. So I hope you have learned how to build a decision tree from scratch and how to visualize the result. So if you like my channel, please subscribe my video. Thank you so much. See you next time.